Hello friends, we are talking about the linear equation in two variables. In the 10th standard, we know how to find the solution of the linear equation in two variable. There are different methods and there are geometrical and algebraic methods are again there basically two types. In geometrically we show them in a graphical way. In an algebraic way you have to use the elimination method to find the equation of the linear equation, solution of the linear equation in two variables. Again, further is another method, that is by Cramer's method. You have to find the discriminant and then find the values where the two lines have the solution. And I'm talking about the general, what means the linear. Linear means it represent a straight line. Linear equations have a pair of equations, a linear pair. When the two linear equations in the same two variables are called a pair of linear equations in two variables. The general form of linear equation in two variables are a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. And I'm talking about that, what is the solution, what means the solution for these two lines. Either the point, a pair of ordered pair of points, ordered pair represents a point, and that satisfies both of these equations. You call them as a solution of these two equations. What about the solution? That point lies on the both line. It satisfies the both equation. It means that lies on the both line. On the basis of the roots of the linear pair, there are some different type of equations of the lines here. The linear pair of equations are of three types on the basis of nature of the roots of equations. First one is that is a consistent lines. The lines which intersect each other and have a unique solution means a point is a common on both the lines. And what is the condition for that? In that condition, a1 is upon a2 is not equals to b1 upon b2. And then in the sense of the order, there is an inconsistent means, what about there? There is no solution, means there is no common point is there and the lines are parallel to each other. And the third one, there is a dependent and consistent. It means that the lines coincide each other, means they represent the same line. The different name of the lines are shown, but they represent the same line, means the infinitely many points lies on both lines. That's why it has the infinitely many solutions. Let's observe through the practically on GeoGebra. I'm going to show these, what is a consistent lines, what is the inconsistent line, what is the dependent and consistent. We go to the say on the GeoGebra. Now this is a GeoGebra interface. On the GeoGebra interface we are looking is at a graphical view, and there is a different views are here. Here is a graphical view of the GeoGebra, and it is a algebraic view of the GeoGebra. I am taking the equation. For first is there is a consistent equations. What is a consistent equations? First of all, what is a linear equation in two variable? Means it has two variables and the degree of each term is 1. That's why it's called a linear equation in two variables. Now I am showing you the nature of the consistent, inconsistent, and dependent variables. I'm using this keyboard here. Let me I'm taking the example of that 2x 2x plus 4y equals to 6 is the first line. This is the equation of these lines I'm showing here, 2x plus. And then I will take the other line, that is x plus y equals to, that's a 4, and this is a second line, and these both lines are intersecting to each other here. Now this is equation 1, that is x plus 2y equals to 3. The other line is that is x plus y equals to 4. These two lines have, there is an intersection here, and that point of intersection I will mention here. What is the name of that point? That is 5 comma minus 1 is the point. And if I put the 5 comma minus 1 in the first equation, that is a 5 minus 2, that's 5 minus 2 into minus 1, that's minus 2 equals 3. And if I put 5 and 1 minus 1 in the second equation, that gets the value 4. That's the point satisfies both the equations, that why it is a solution. Now I am moving to the next. There is another example I will show you. If I take the line, if I take the first line, there is, and I want to draw the line parallel to the given line, that is I am doing the line parallel to the given line. Okay, I'm doing the line parallel to the given lines, and I will show you. If I move it, it is not moving. Okay, this is a line of equations where I am showing these equations of these lines, and this is a 2x plus 4y equals to, that's 19.7. If I move this line again, if I move this line, then what happens to this line? If I take this line and if move, then can it move? No. Okay, if I move this line, I will not move this line, this is a fixed line. And select this line and move. Now what I get, the change in, it's not moving. But if I move this line, I get the change in, what is the changing values? Look at there is the first equation, x plus 2y equals to 3, and the second equation is 2x plus 4y equals to, that's a changing c1. If the point C changes, I am holding the point on that line, and if I changing the line which is parallel to the first equation, that is x plus 2y equals to 3, and if I changes these lines, place of this line, it is parallel to first one, there is only change in C. It means that whatever may be the values of these x coefficient and y coefficient have the ratio same, that is here is 1, here is a 2, there is a ratio is 1 by 2, here is a 2 by 4, that's equals to again 1 by 2, means a1 upon a2 equals to b1 upon b2, and there is a not equals to c1 upon c2. C1 is a changes, c1 and c2 are changing. As I am moving these lines, the values are going to change. That's about the two lines are parallel, there is a no solution, there is no any common points on the which satisfy both the lines, and that's why it is a inconsistent solution. Then I will take the other example of the line, that's I want to show you. This is the first line, that is obviously we know about that line, that is x plus 2y equals to 3, the equation of that line. Object properties, and I will show the name and value. This is the equation of line, I am showing. What about the next is there? I am putting the next equation, that is 2x x plus 2y equals to 3. I am writing there is a 4x 4x plus there's a 8y 8y equals to 12. Okay, what is the equation where the line goes, and this line coincides with this I have entered, and you are not seeing any special lines. That means, what it means, I have the first line that is x plus 2y equals 3, and the next one that is a line that is 4x plus I have drawn that is a 4x plus 8y equals to 12, and this line have the same nature, and that's not seen here. It means that both the lines are coincide here, and it shows that it has infinitely many points which satisfy both the line. That's about the nature of the lines. If you know about that, if the two lines are there, what is the nature about that? The line may intersect, we call them as a consistent, they have a unique solution, one point is a common. That's the root of that lines. And if the lines are parallel, then what is the condition for consistent and unique solution? The lines are intersecting, that is a1 upon a2 is not equals to b1 and b2. That's the condition for the consistency for unique solution. And if non-consistent means they are parallel, no any common solution. In that condition only a1 upon a2 equals b1 upon b2, but that's why not equals to the c1 upon c2. That's the inconsistent. And dependent and consistent means both the lines coincide each other, they have infinitely many solutions. There a1 upon a2 equals to b1 upon b2 equals to c1 upon c2 have the same value. There is a multiple of it only, they have infinitely many solutions, represent the same line. And thank you for this, and this is the linear equations nature in the graphically. I am stopping now here. Thank you for listening me.